in action. This is a whole day webinar event with morning session from 9 a.m. to 12 noon, and then we will have a lunch break, then afternoon session from 1 p.m. to 4 p.m. We want to acknowledge the presence among us this morning, Dr. Randy S. Gamboa, Dr. Maureen Mamilik Villamor, and Dr. Tamara Chair Mercado, academic personnel from the University of Southeastern Philippines, College of Information and Computing, and also for the presence of all the participants. We welcome you all for this event. To start with our event, let's first have the opening prayer, then followed by the singing of national anthem.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فقال ربكم ادعوني أستجب لكم آمين يا رب العالمين الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين اللهم اجمع شامل المسلمين والكريستيان والأمة في مدينة دماو وسلم دائما مجتمعنا هذا بالسلم والأمن والتقدم في بلدنا هذا آمين يا رب العالمين ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على خير خلقه سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين آمين يا رب العالمين.
In the name of the Father, Son, and Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you, when we forget to acknowledge your presence in the image of our brothers and sisters, and for moments we fail to be good stewards of the blessings you have given us. Continue to guide and protect each one of us, Lord, that we may always walk in the light of your everlasting love and mercy. Grant us, Father, with your comfort in times of distress and with your strength in times of weakness. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with the prayer and the intercession of our Blessed Mother. Amen.
Manama, mabantog ka. Warag po ko ilingkoy ko. O Diyos, kahibulungan ka. Busa ikaw lang ang simbahon ko. Busa ikaw lang ang alagaran ko.
And to formally start the event, let's hear the opening remarks from Mr. Inglebert Houtin, a College of Information and Computing Graduate School student. Sir?
Good morning, everyone. Speakers, participants, Mr. Randy S. Gamboa, and all of our guests, welcome. My name is Inglebert Houtin, and it is my privilege and pleasure on behalf of University of Southeastern Philippines College of Information and Computing Graduate School to welcome you here today. We are delighted to have you with us to participate and share in our Artificial Intelligence and Machine Learning in Action webinar. Thank you for coming. That each of you has did your best to allot your precious time to be here. Serve us as a reminder to us all just how important our work is. University of Southeastern Philippines College of Information and Computing Graduate School is committed to actively raise the quality of learning in artificial intelligence and machine learning. We want all of you to achieve your full knowledge and potential in this field. Our task is to make it possible, and our mission is to provide practical, step-by-step assistance or learning. We are honored to have Miss Julia Camille Las and Mr. Albert Humor. Our speaker are STEM specialists in doing artificial intelligence and machine learning. Now, prepare yourself to get learn further, to be challenged, and even be inspired. And before I hand over to Miss Ceresa May Torino and Mr. Cameron B. Nieve, our host, who will outline these webinar events, I want to say once more, on behalf of the University of Southeastern Philippines College of Information and Computing Graduate School, welcome. It is wonderful to virtually see you, many of you here today. Thank you. Ma'am says.
Thank you, sir. Thank you for the wonderful opening remarks, sir. And reminding you all for the question and answer, You may send your questions to our Zoom message box located at the bottom right corner of your screen, or post your question to our group page. And since we have limited time, the remaining unanswered questions will be sent later to the speaker, and the answers will be posted in the group page, the Artificial Intelligence and Machine Learning in Action page. And without further ado, let me introduce to you our first speaker. Our first speaker is Miss Julia Camille Las. She is a graduate of Bachelor of Science in Biology at the University of the Philippines, Diliman. She has a training and certification as Data Science Fellow at Sql Labs. Her specialization are data wrangling and data visualization. She is currently working as a data science education specialist at Sql Labs. Help me welcome and give the time to Miss Julia Camille Las. Ma'am?
Hi, yes, good morning, everyone. Thank you, Miss Teresa, for that introduction. Thank you. Thank you very much. So, good morning, everyone. First of all, I would like to express my gratitude to the University of Southeastern Philippines for inviting me to this webinar. It's my first time to deliver a lecture for a Mindanao-based university, and it's truly an honor to be in your presence right now. I'm very much excited to spend this morning with everyone in this Zoom call, as well as all of our viewers via Facebook Live. So today, my goal is to introduce to you to the world of data science. As an advocate of data-driven solutions, I hope that this lecture will inspire some of you to be data scientists as well. So specifically, this morning, we will be talking about machine learning with a focus on unsupervised machine learning. Okay, so let me share my screen. So once again, good morning, everyone. I'm glad to see that there's a lot of eager participants here at the Zoom call. I've heard that we have over 100 people who have registered and are viewing. So it is really nice for you to have to give time this early Saturday morning to join us. Okay. Okay. So, yeah, thank you for that introduction. Again, I am Julia. I am a graduate of University of the Philippines. So, surprisingly, I'm actually not an IT graduate. I'm a scientist, but not. But before I shifted to data science, I was actually a real scientist, being a biology graduate, and then I shifted as into data scientist. Currently, I work as a data science education specialist for Sql Labs. Sql Labs is an edtech startup wherein we prepare people to the future of work by providing boot camps and programs that will assist people who wants to shift careers or who wants to be able to prepare themselves with the current trends in technology, such as data science. So in Esco Labs, for example, we have our data science bootcamp, wherein we have a 12 weeks program where you can learn a lot of things such as machine learning, natural language processing, etc. So yes, so before going to data science, I've also worked with a lot of government institutions as well as NGOs, and personally, I am just simply also just a laid back person who likes to enjoy the simple things in life, such as being outdoors and going to the beach. Feel free to connect with me with my LinkedIn and GitHub. Just send me a message, let me know that we've met in this webinar, and be glad to be able to connect with all of you after this event. Okay, thank you very much. All right, so let's get straight to it. We have a long lecture today. It's a couple of hours long, so please but I like to keep my lectures casual, so but please feel free to just relax while listening. Also, by the way, we will be using Jupyter Notebook for this lecture later on once we do our code along. So if you are familiar already, please download Jupyter Notebook via Anaconda. I think the organizers can share the link. Okay, but later on I can also share it with you. So But for now, let's focus first on the concept. So machine learning. I know that a lot of you are probably already familiar with the concept of machine learning, given that most of you are coming from a computer science background. So machine learning is the field of study that gives computers the ability to run without being explicitly programmed. So as we know, like normally when we train our computers, it's like we explicitly program it. We call it the rule-based model. But then there's another field called machine learning, wherein we don't use rules-based, but instead we feed information to the machine, and then it learns from those informations that we feed it. So one way to explain machine learning is using the formula that it improves the performance P at some task T with experience. So what is a performance? Performance is, for example, like performance is like how accurate your model works. So one way is like saying in a classification model, how many percent of the images was it able to classify correctly? So that is the performance that we're aiming for. So if you're familiar, like for image classification, you know that we give the machine multiple models, and then we want to assess if is able to give us the results that we want. Say, if you want to be able to classify a photo as a dog. So to do that, so that is the task. The task is recognizing the photos as a dog. And then to be able to improve the performance, we feed it multiple photos, multiple images that are labeled so that it gains experience. So similar to humans, right? That's usually how we learn, like, through experience. So yeah, as mentioned, just a recap compared to traditional programming, wherein we feed the data, we feed the program, and then we create rules to give the output. In machine learning, we usually feed the data, we specify the output that we desire, and then the machine give us back the program that we need. All right, so where is data science or machine learning used nowadays? So you might be familiar as my first use case. It's image processing. It's a very common tool for very common use case for machine learning. So if you guys are familiar with the K-drama startup, Samsung Tech, they were using image processing to be able to help the grandmother, yung Laura, right, to be able to help her identify when she was losing her eyesight, di ba, nung nawawala na yung eyesight niya, they were helping her using image processing to be able to identify what are the things that she could see. So that's a very interesting use case. And right now, there's a lot of developments in image processing. Another one is natural language processing. So what is natural language processing? That usually involves text data. So if you have seen like summarization tools, like for example, for you who are students right now, you're probably encountered like reading a lot of journal articles. Diba? As students, we tend to read a lot. We're given a lot of readings, a lot of journals to process. So the natural language processing, one of the things that they're trying to develop right now is like being able to summarize all of those things into an efficient way. So that's an example of natural language processing. And then there's also for a more applied approach, for a more industrial approach, we have, for example, for banks, one of those that are practitioners of machine learning, they do credit risk analysis. So they identify which accounts are at risk, which accounts are most likely to default. So those are common use cases for banks, for those who are thinking of like, how can I apply this after, like, to work that is more into like the industry right now. And then in terms of our day-to-day lives, you guys might have been familiar already with recommendation engines. So if you're into e-commerce, the e-commerce platform out there, Shopee, Lazada, they usually recommend once you're able to order something right after you mag-add to cart, they would now recommend additional items for you to buy. So they would have a recommendation engine that is tailored fit so that that make your life easier, like making finding things easier. Aside from e-commerce, syempre, you have our favorite like platforms that we use, Spotify, Netflix, all of those use recommendation engines. That is a machine learning model behind it that tries to recommend to us which one should we watch next, listen to next. And then there's a whole lot of other classification models out there. For example, just in terms of your email, if you use Gmail, it can classify spam and not spam. It can classify yung mga, right now, it also has a way to classify yung mga promotional versus social and your primary. And then even outside of that, there's a lot of use cases for like classification and predictive models. So there's a lot of opportunity out there if you want to be like if you want to go to the field of machine learning. Actually, it's as cliche as it's been sound, it's been said that time and time again. It's like the sexiest job of the 21st century, simply because right now, we're at the age of data. There's a lot of data available, so we need more people to handle this data. Okay, so so now that I've introduced you to machine learning, let's talk about the data science process. So I think this is just a version of the data science process. There's a lot of different versions out there, but this one is an easy one to absorb. So why is it important to think about the data science process? So normally, we tend to jump straight to a machine learning approach where we want, especially people who are very technical, right? They want to go straight to doing the modeling by making models. But sometimes it's better to go through the process, the data science process. It's the reason why it's called data science, right? Because they're anchored towards they're anchored towards the scientific method, wherein there's really that rigid process of what you have to follow so that you're able to get a good output. So it's not just like going straight into modeling or like jumping straight into the code. It's always better to go through the process so that it would make your results later on it would make your results like more meaningful and more useful to whoever it is you aim for the model to benefit from. Okay. So we have sorry. So we have 6 parts here. We have the business understanding, the data understanding, the data preparation, modeling, evaluation, and deployment. So let's go through it one by one. Okay, so first we have the business understanding. So learning experts often didn't build their work around the final objective, deriving business value. So this quote was taken from an article in the Harvard Business Review that's asking why you're not getting value from your data. So this is often the reason why for some people who are even working in the industry, they're asking, why isn't my upper management buying into my data science project? Like, I want to do this, pero bakit hindi ina-approvean yung project? Why am I not getting support? And usually it's because you fail to communicate the business value of what you're doing. What do you mean by business value? Yeah. So by business value, mean what is the purpose of your model? So yeah, I most of the time we have a lot of interesting passion project, but it always have to boil down to what problem are you trying to solve? Ultimately, machine learning data science is a problem solving exercise. It's there to give solutions to problems that we have in society. So you should be able to clearly pinpoint from the start what problem are you trying to solve. And then ultimately, if you really want to derive business value, you have to be able to answer the question, what do we gain from building this model? So karamihan, di ba, there's lots of time where we build model and all of that, but then they don't know how to deploy it, or they don't know okay, so how does the company or the institution benefit now from doing this model? To think that making models sometimes are resource heavy. It takes time, it takes energy, it takes resources if you need yung mga upgrades in your computers. So you have to justify that by being able to say that what is the business value? What do you gain from this? For example, you can say na, by doing this model, we're able to save on time, which later on would eventually lead to a an increase in revenue kasi nakatipid tayo. So those are examples of business value that you have to be able to communicate well with you have to be able to communicate well with your stakeholders. And whenever you're doing a machine learning project or data science project, always keep that in mind. Always keep in mind, what are you trying to solve? Okay, because sometimes you can get overwhelmed with all of the processes that you're doing. that you try that, and or sometimes it can the other way around. It can get very exciting, diba? Like, oh, I want to try this. I want to try this. Lalo na ngayon, if you're familiar with yung mga towards the science medium, there's so many things that are very exciting to try. But always go back to your purpose of what is it that you're trying to solve. All right. So next we'll go to the next part, which is data understanding. So an American novelist once said that numbers don't lie, but humans do. Okay, so most of the time, like, we can fall into this trap that when we don't understand our data, we tend to handle it. We tend to handle in the way that it may not be as accurate, or as it may not be as accurate, or it may not be used as how it is intended. Kasi especially if you are familiar with Kaggle, which is data science, like competition space, wherein you also share data, or right now there's a lot of information online. There's a tendency to copy code. You just copy paste code without thinking anymore na, is it applicable to my data? Is it applicable to the data that I have? So by doing that, eventually, like, it's either your model doesn't make sense, or your model minsan pwede kang sumamba, like your model would still like get high accuracy, but what would happen is that you're not able to interpret it. You cannot defend it later on, since like you didn't really understand the data that you're handling. So here's a quick example. So for example, for this one, this calls the Datasaurus dozen, right? Because there's a dozen of them and then there's a dinosaur. All right. So for this one, if you look at it, it has their mean. We have the mean value, your average value of all the points. And then they have your standard deviation, and then your correlation. And then for all of these 12 items, they're all the same. Kumbaga, if you get the summary statistics of this, it's all the same. So sometimes if you don't understand your data, if you don't take the time to go to the extra layer of going deeper into knowing your data, and like just look at the summary statistics, it can be misleading, or like it might not be tell the whole picture. Such as in this one, like you like, remember, data science, and it's all about like finding patterns in data. So if you don't really take the time to understand the patterns in your data, then you can sometimes be misled. Okay, so I'm not sure if any of you are familiar with this, so I'll give you a few seconds. Does anybody have an idea what this is? Yeah, so this is actually what we call data dictionary. Sorry. Here. A data dictionary. So most of the time when we're handling big data, especially company-wide data wherein there's a lot of sources, you should have a data dictionary that tells you what your variables are. Because sometimes it's not as intuitive as we think. Sometimes a number can be, like for example, you have gender and it says they're 1, 0. If you don't have a data dictionary, how would you know which one is male, which one is female? Do you just assume? Diba? Automatically, mali na yung analysis mo if you interchange that. Right? If you have 1, 0 and you don't have a data dictionary to tell you which one is 1 and 0, and you just assume based on whatever bias you have, like feeling mo mas madami yung guys or girls, then it can actually screw your analysis already. So it's very important to know your data dictionary. It's very important to understand what your variables are, what you're dealing with. And oftentimes, it's not even enough to just work on this solely. You might need to be able to collaborate with domain experts, especially for those that are very technical with domain. Like, for example, when COVID data, like for example, the COVID data very uso right now because everybody like wants to be able to help with COVID. But if you're like a statistician or a computer scientist and you try to work with COVID data without knowing what the variables are by for example consulting with an epidemiologist or a health expert, then you can actually misinterpret the data, which was like a subject of a lot of debate earlier when a lot of data scientists were trying to create models without actually understanding the domain that you're trying to do. So it's important for you to know your data dictionary and also know the limitations of what you know in the event that it's not enough, like be able to collaborate with people. Data science is a very collaborative field. The best projects are those done by multi-sectors. So always be open to collaboration. Okay. All right. So that's already a lot. So we're already at the third part of our data science process, which is data preparation. So here I'm just showing some of the most common tools that we're using. I'm not sure how familiar you guys are with these tools. We have Pandas and Numpy. So these are the data wrangling and data transformation tools that we're using, that we use most often in data science projects. Later on, once we go to our code along, you'll be able to work with these packages yourself and be able to try them out. Right. So in data preparations, it's just making sure that your data is ready if you want to be fed to your models. So you have to do your standard data check, such as one, are there missing values? Most of the time, data is not clean. Yeah, like almost all the time, data is not clean unless like it's already been cleaned by someone else. So one thing you can consider there is, are there missing values? What do you mean by missing values? Like sometimes it's really blank, are there blanks? Sometimes there are values naman that aren't supposed to be there, like it says none, all of those things. Are there illogical data? For example, what if you're working with age and then there's an age that's like 999, right? Then you know that that is not a logical age. Diba? I don't think anybody here right now is 999 years old. So if you have those kinds of data, what do you do? Are there outliers? That's another thing to consider, because like how do we handle outliers? Like once you have outliers meaning like if you have a range of numbers, those that are exceptionally high or exceptionally low. Like I guess 999 can be considered as an outlier, but it's also illogical, right? But there can be logical outliers, such as when working with money, di ba? When we're working with yung pera. Normally you have a range, for example, income, di ba? You have a range of amount that people earn. Like, let's say, I don't know, like 30,000, 40,000, like that, like probably within zero, or within probably like 15,000 to 100,000 or 200,000. But then you have outliers, right? You have people who are earning like millions and all of those things. So more, how do you handle this thing? So when you're performing data checks, the main question that you really have to answer is, how do we handle the data? And there's really no one-step solution to it. Like even handling missing values, handling outliers, it really depends on the business case, like on how it applies to the business. That they're the ones who, the business case is the one who will be able to tell you, like, should you drop it, should you impute, should you like add, should you like get it back from, like, should you confirm from the source. So when you're performing these data checks, you have to check, you have to you have to have that domain knowledge as well to be able to know what to do. Okay, so now we're at I think the part that people are most excited about. So mostly like the first three parts, those are things that people tend to avoid or like don't really want to dwell that much time with, yung data preps, kasi nakakatamad maglinis ng data, ang hassle, yung ganun. Although it's the bulk of actually what you're going to do. Syempre, data understanding, business understanding, most of the time it's taken for granted, but as I've mentioned, don't. Right, but now we have the modeling stage. So the modeling part is where we apply our machine learning models. So in terms of machine learning, we have two kinds, two major classification: supervised and unsupervised. So in terms of supervised, you can classify also as classification models or regression models. So, and then unsupervised, you have clustering, and then you also have others such as latent variable analysis. All right. So how do we differentiate supervised and unsupervised machine learning? So for supervised machine learning, it's usually finding patterns it's usually a prediction task. So you have an end goal, such as you want to classify email as spam or not spam, right? So you have that end goal, and then you want to be able to predict. So that's a classification problem. You want to classify it as spam or not spam. And then usually you have labeled data already. So you already have examples of data. Meron ka ng rows that are classified. Meron na siyang label as spam and not spam. And then from that, given those labeled data, you want to be able to create a model that you can evaluate and how accurate it is in being able to predict those that it's not available. So you have your data that is already labeled. So now when you feed it new data that it has not seen before, how will it perform? So that's usually like the main idea for supervised machine learning. Literally supervised, like you feed it the label, and then you try to tell him that this should be the one, this should be how your output is like. In terms of unsupervised, it's the other way around. So it's finding patterns in data without a specific prediction task in mind. So sometimes this can be an exploratory stage, but sometimes it can be an end goal in itself. So the algorithm uses data which are not labeled. So it doesn't have that column that says this is our target variable. It doesn't have that. It only has input variable. So from that input variable, it tries to find patterns in data and give you the results that you want. So a common example for that are your clustering, wherein it groups on itself. Like imagine the boat is sinking. The game na yung the boat is sinking, if you're familiar, di ba? You just tell them na, oh, the boat is sinking, group yourself into 3 without giving it instructions na how should you group yourself. So that's usually how unsupervised machine learning works. Compared to supervised machine learning, sometimes it's more difficult to interpret because for machine learning, especially for like linear regression, you can easily see the output. Like you can have metrics such as accuracy, precision, recall. Kasi you have all those metrics like your error, your mean squared error, to say if something is a good model or not. And then at the same time, you can also be able to know which features are able to contribute to that result, bakit siya accurate yun. So sometimes the features. So it's easier to interpret compared to unsupervised learning, wherein it's very difficult to evaluate since you normally there's no gold standard. Like there's no like 100, for supervised, you have like 100% accuracy that you're trying to aim for, although most likely you're not going to get 100% accuracy, but you know that yung merong gold standard. For unsupervised machine learning, there is no gold standard. So it's really up to your it's really up to your domain knowledge to say that, is this a good cluster? Is this a good model? All right. Okay, so after we've modeled, as I've mentioned, we have to evaluate. So I already mentioned some of the metrics that we use. So for supervised, we have we have our for supervised machine learning, accuracy, precision, recall, root mean squared error, all of those things. Yeah, so that's usually how you excuse me. So usually that's how you evaluate the performance of your models. But there's another factor to consider, which is the interpretability. So as I've mentioned a while ago, interpretability basically says like what is the basis for the results. So sometimes you can get high accuracy, like 90% plus accuracy. But when they ask you like, oh, why is it high? Like why is the accuracy high? What caused it to be high? And there are certain models wherein it's hard to interpret na hindi mo masabi why it's high. You just it just an accuracy score. So it depends. For some use cases, like for some companies, for some clients, they only care about the performance metrics. So you just need to have a high accuracy. Like for example, classifying dogs in an image classification. Normally you don't really care, or like we don't really think anymore na why is it classified as a dog, diba? Like most people, like we don't really think anymore if does it matter or all those things. What we're really just aiming for is how many dogs was it classified correctly. So that's a performance heavy evaluation, which is in that case it's okay, like, for it to be performance heavy. However, there are certain cases that where interpretability matters. So like for example, for banks, when they're like doing credit risk analysis, excuse me, when they're doing their credit risk analysis, di ba, parang they need to know why that person is defaulted. Di ba? Why did like for example, if they tell you that we cannot give you a loan because your credit score like didn't pass, like the classification was loan. You cannot, like if they ask why, you need to be able to say why. Like that's enough interpretability for those use cases that needs interpretability. Like you cannot just say na parang, oh, the model says so. Diba? Parang, it's not fair in that cases. So those are the examples of cases where you need to be able to interpret your models. So the trade-off between performance and interpretability depends on like what is your objective and like who will or what is like the end goal. Again, going back to the business understanding part. And of course, interpretability is also like how can the results be applied to the initial problem? Like going back to the business understanding, how can you apply it to that one? All right. So now we're at the last stage, deployment. So all right. So you already have your model. You're ready. You prepared your data. You did your modeling. You did your evaluation, and then you got great results. So you had a cool model. So now what? Diba? So what's next? So most of the time, or sometimes there's that data science trap, especially for junior data scientists, wherein they make a lot of models, but then it ends with them. Like they share it in GitHub and all of that, but then it never really gets deployed. Like nobody becomes the users of those models. But the most successful data science project are those that are used by people, such as those by Netflix, Spotify, YouTube, Facebook. The reason why these are big, these companies are so big is because they have so many users and um, so many people benefit, or well, you can say benefit, right? But basically use their machine learning models. So that is something that you have to keep in mind also. I mean, maybe at the earlier stage, it's not that much of a priority. But when you're making a model, you have to also think, how can people use this? What platforms can I use to deploy it? What are the tools that they can possibly need? Who can I collaborate with? Do I collaborate with web developers, with app developers? Do I collaborate with them so that we can deploy the model? Because it's useless to have a model if it's just like in your computer, in your Google Drive. Like somebody has to use it. So you have to be conscious. You have to be also curious of how you deploy something in production. Okay. So that's the data science process. There's a lot of so we have six steps right now that we've shared. Although I think as you've noticed while I was talking, these steps are not one. It's not chronological. It's not one after the other. It can be very iterative. For example, you could be preparing your data and then realize while preparing the data na, oh, I don't understand what this variable is. So you go back to data understanding. Or sometimes you can be in the evaluation phase already, and then you realize that while evaluating your data, you realize that there's like a disconnect between your results and the problem that you're trying to solve. So you go back to the business understanding. So it's an iterative process. It's not a linear process wherein you go from one step to another. There's really a lot of iterations involved inside that would that would really allow you to take your time, and to it really allows you to be able to go in depth to what you're trying to do. You need to be able to go to this iterative process wherein you go back and forth to every step until you finally reach the one that like satisfies your ultimate goal. Okay, so we have a lot of participants now. We have over 100 participants in the Zoom call. Okay, all right. So this is the first part of the lecture before we go to the technicals of machine learning as well of unsupervised learning as well as the code along. So at least for this part, are there any questions in the room? Is anybody like I'll probably give a minute or so if there are any questions. Mm-hmm. You can type in the chat or maybe in Facebook. All right. One question is, can I use Spider IDE? Yes. You can actually use, but it's not advised. You will see later why it's better to use Jupyter, why it's the go-to tool for data scientists. But yes, you can actually use any IDE for doing data science projects. Mhm. All right. Yeah, just feel free to type in your questions in the Facebook group or in the Zoom call if you have any. Okay. Okay, all right. So let's go to let's talk about unsupervised machine learning more now. So as I mentioned, this lecture will focus our code along or our walkthrough will focus more on unsupervised machine learning. So unsupervised machine learning is all about finding patterns in data without a specific prediction task in mind. So particularly for this one, we'll be focused on clustering. So clustering is basically finding subgroups finding subgroups in a data set. So literally like forming clusters. You know, clusters are like yung mga groupings there. So as I mentioned, it's like the boat is thinking, you find groupings in your data set. So we want to partition our data set in such a way that those who are most similar are closer to each other, while those who are different are farther away from each other. So we want to minimize the distance between those that are more related and like maximize the distance to those that are less related. So that's how clustering technique works. Right. For this one, what we will introduce to you is a very one of the more common tools for unsupervised machine learning, which is the k-means clustering. So the k-means clustering is an iterative algorithm that partitions the dataset into distinct subgroup. How does it work? Basically, each data point belongs to only one subgroup. So that's how. So for k-means clustering, there's no bawal yung nangapit bahay. You only have one group. You cannot go to another group. And then, yeah, so you want to make the intercluster data points as similar as possible while keeping the clusters as different as far as possible. So the algorithm behind this is it's actually quite simple. So first, it just randomly assigns a number from 1 to k to each of the observation as initial assignments, as you can see in step 1 here. So where each point will be assigned a number, and then from there uh, it will compute the centroid nung points na yon. So it will look like from this point which is the centroid sa yung gitna niya, this random points. And then it would now recalculate it to reassign which points are closer to this new centroid. And it will keep on doing that. So for each of the K clusters, it will compute the cluster centroid, tapos it would reassign the points around it until eventually it finds the right grouping. So as you can see here, initially parang it's just a jumble of colors, right? Tapos within this jumble of colors, since most likely its centroid is in the middle, or ganyan yung like if you can look at yung iteration 1 step 2a, it's mostly everything is like mostly there. But then you're starting to look at what points are closest to these centroids and yung pinakamalapit. So I guess yung mga yellow ones are the upper ones probably. Then the pink ones are the lower left ones. So now it readjusts the points to it reassigns them, and it keeps on doing that until it gets to your final result. Okay, so that is like, so keep this in mind later when we're doing the k-means clustering. So this is like the theory behind it, but I know that you guys are more excited with the application. So to be able to code along, please um, go to my GitHub, github.com/julia/. And for this one, I made the repository usep_AI_ML. So I'll give you guys a minute to download. So there are two files there in that GitHub. One is the Jupyter Notebook, the .ipynb file, and the other one is the dataset, which is a CSV file. All right, so while some people are downloading, you can ask questions in the chat. So one question is, do we need to study probability and statistics to implement data science and machine learning projects? Yes. Most of our machine learning project, especially most of the machine learning project deals with probability, like what are the chances that this thing is classified to this. So you need to have a basic understanding of probability and statistics to understand your model. Admittedly, there is a way na parang you can copy codes, tapos it would run even if you're not familiar with data science. Like it would work, but it's not ideal that you're like you have results, pero it's not very like you don't understand why the results are like that. So that's why you need to have a basic understanding of probability and statistics. And at the same time, like to make good models, you need to understand the distribution of your data set. You know, you need to understand your distribution. As I mentioned, I showed a while ago, like it's all about finding patterns in data. So you need to know and if it's skewed, if it's like normally distributed, what are like, all of those things. It would really help like fine tune your model later on. Okay, I hope people, those who are in class are able to, are in this webinar, are able to download the notebooks. So I will share my screen now to show you how it looks like. Give me a few seconds. What certain topics in statistics should we focus to study? So if you have your stat 101, another question, what are the things in statistics you should focus on? So everything covered in your stat 101 is important. So everything about probabilities. Probabilities is very important in statistics. Bayes theorem, if you're familiar with Bayes theorem, that is already we actually have a machine learning model called naive Bayes, which is like very close to Bayes theorem. All of the basics as well dapat alam niyo, like the what you call that, measures of central tendency, measures of dispersion, as well as the central limit theorem. And then it would also help if you have an understanding of yung mga hypothesis testing, as well as yung mga and of course regression. Regression is very important because we do have linear regression models, all of those yeah, basically when it comes to regression models in machine learning, it's finding the best curve fit in the line. So having an understanding of linear regression really helps. Okay, so if you're able to download the notebook and open Jupyter, yes, I hopefully you guys are quite familiar with Jupyter notebook. Um, this is how it looks like. I know it's for those who are more into the computer science space. It's not something that you're it's not something that's similar to what you're using with yung usual na text file. Di ba? Normally, we just have a text file and yung mga IDE natin na that has like text file pero color coded. So Jupyter Notebook really looks like a notebook. So if I scroll along, you can see that the reason why data scientists likes it kasi it's you're able to put everything inside. Like right now, I can even give a lecture with just a notebook. So you can put markdown text. Sorry. There, so you can put text if needed. For a while, my computer is hanging. You can put text. You can put images. You can even put and then you can also put how you call it graphs. So that's like the advantage of Jupyter Notebook is that it's very easy to do all the things that you need for data science. And you can even like document it well. So here we've already discussed most of these initial parts: introduction to unsupervised, supervised versus unsupervised, data science process. So let's go to this specific use case that we have today. So today for this unsupervised machine learning project, our focus will be on customer segmentation. So what is customer segmentation? This is a very popular tool that most of like marketing people use, marketing and sales people use. So normally you have a set of customers, right? You have your database of customers, but then you cannot target your customers individually, like one by one. You have to group them together so that you can form strategies. Like for example, if you notice this grouping has this certain personality, then it would be easier for you to target them. You know, you can like say na, oh, itong mga taon to, they're the ones that are they're the people na parang are easily to buy, yung ganon, they're like our fans. So then now you know how to approach them. These people naman, they're the ones that are detractors. Sila yung mga who say bad things about us. So how do we deal with them? So customer segmentation like allows you to be able to group your customers into different personalities, like big personalities, so that you can address it easier. So this is a lot of use cases, like a lot of companies. Customer segmentation is not new and it's not unique to machine learning, but the traditional way of doing customer segmentation was by basically using simple math. Like they give points for behavior and all that, then they combine those points. So it was it's a very manual process. So right now we will try to see if, especially if so that like doing that one, like that manual process, you can probably do it if you have thousands of customers. But once you have millions of customers, that would be quite impossible to do. So that's like how machine learning helps. Then when you have more customers now, then better to have machine learning tools to help you be able to do your segments. Okay, so for this one, our focus for our, remember, we always have to start with our business understanding. So that is our main goal. Our main goal is to cluster our customers so that we can be able to identify how to approach them later on. All right, so our main tool for clustering them would be what we call the RFM: recency, frequency, and monetary value. So recency is how recent a customer has made a purchase. Frequency is how often a customer makes a purchase. And monetary value is how much money a customer spends on purchases. So very intuitive naman. Diba? Recency is kailan sila huling pumunta. Frequency is gaano kadalas sila pumunta. And then monetary value is gaano kalaki yung ginagastos nila. Diba? So very intuitive. Okay. So So when working with machine learning models or data science project, we normally have our favorite packages. So this is like our go-to packages for our pre-processing. We have our pandas. So this is how we import packages in Python. I think most of you are familiar. So you just type import, then the package name, and then you can type an alias after, such as this one, as PD. But you don't have to write pandas all the time. Numpy, like it makes it shorter if you have this aliases. So these are the conventional aliases that we use for so these are the conventional aliases that if you go to Stack Overflow or if you look at other people's GitHub, they're probably using the same. So what are these libraries? What are these packages that we're using? So Pandas is a fast, powerful, and flexible, and easy way to use data analysis and manipulation tools. So Pandas is for data wrangling. What is data wrangling? It's basically data wrangling is basically being able to be able to transform the data according to how you want the data to look like. So sometimes the data is not in the form that we need. We want to change columns. We want to add columns. We want to pivot it, all of those things. So Pandas can help. Like we want to aggregate some terms. So Panda is very useful and it's very user friendly. As we go through this notebook, you'll realize that Panda is very nice because it's very close to English. Like most of its terms are really just like English. Then we have Numpy. So Numpy is used for working with arrays and matrices. So since for data sets, if you think especially though for with the computer science background, you're probably familiar that like data in a n-dimensional space can be converted to arrays and matrices, right? So you can have multiple arrays for multiple dimensions. So to be able to handle those dimensions, you can use Numpy. And then Matplotlib is a library used for visualization. So it can give us simple graphs to make our like bar charts, histograms, and then Seaborn is another package made on top of based on Matplotlib. This gives us additional features for graphing, and at the same time it's very useful for statistical very useful for like statistical processes such as like if you want to see box plots or correlation plots. Seaborn has a lot of functions that can easily provide you that. Okay, so to run cells in Jupyter Notebook, just simply you can press run here on top, or you can just click Shift Enter. So Shift Enter is like the shortcut to run the cell, and you know that it's loaded if there's a number here on the side. So when you start typing it, normally there's a blank number. Tapos malalaman nyo na it worked or it's running if there's a number here. Okay. Okay, so we imported the library here. Oh yeah. So yeah, it's because I already run I think the whole notebook, so that's why it's already 39. But anyway, there. So to read the data set, so as I've mentioned, Pandas is a very how do you call it? It's a very user-friendly tool because it works on English. So for example, for this one, to read the data set, you just type in read CSV. So it's a straightforward that. You go pandas.readcsv, and then your data set, the name of your data set in string, in quotation marks. And then here you have your, well, this one is just an additional argument to simplify later on to be able to read the data correctly. Because if you check the documentation of Read CSV, so if you click Shift Tab after the method that you're using, you can look at, there's a quick documentation here. So here you can see that when reading data with Pandas, specifically for Read CSV, there's a lot of options available for us, such as file path. Well, this one is like you have to provide it. But then other things such as headers, ano yung mga columns, like for this one, for dates, what do we do with um, rows and values? What do we do with rows and values that are null? Do we skip any rows? So you can give so many arguments for pandas, for read CSV, I mean. And yeah, so that just by loading the dataset, yung pinaka first step pa lang, when you load the dataset, it already like customized in a format that is easy for you. And then of course we assign that dataset to a variable so that we can access it. Good. So to access the dataset, we just go df.head, the data frame name dot head. So this gives us the first 5 entries of the data frame. Then if we want additional entries for the data frame, then we just put a different number here. So like if you want to have 10, then like you just go df.head 10. Okay, so terminologies. There's some terminologies that I'll be using as I go through the notebooks. So each row can be also called an observation or sample. So you have, so like for this one, by doing dot head, we can see 10 observations or 10 samples. And then our columns can also be called as features. So in machine learning, we call them as features. And then if it's a supervised machine learning project, you usually have one column that is your target variable or your label. However, for this case, we're doing unsupervised machine learning, so we do not have a target variable. Okay. All right. So to check the shape of your data frame, you just have to go data frame name dot shape. So in this case, we know that we have 541,909 observations, or 441,909,000 rows. And then we have 9 columns. So again, data understanding, we have to understand what these columns are. It's not enough that we just simply run them. So here we have our invoice number. So our invoice numbers is a 6-digit number uniquely assigned to each transaction. So invoice numbers, I think the keyword here is unique. It has to be a unique code. So given that, you can already assume that an invoice number is not something that you should be adding. It wouldn't make sense if you add this invoice number and this invoice numbers because they're unique. You know, it's like a primary key, like it's a specific code. Then you also have your stock code, I guess, for your stock, and then your product name for the particular product. Quantity, how many of that product per transaction. Then day and time of transaction, so kailan siya ginawa. Product price per unit in sterling. So this is important. Here, the keyword probably that you have to consider is one is per unit, so you know that it's per item. And the other one is that it's in sterling. So again, as I mentioned, you have to be conscious with understanding your data. So here you know that it's in sterling pounds. So it's not in USD, it's not in PHP, because that can affect your interpretation later on. Like, I mean, just you as when you're doing your data analysis, exploratory data analysis. Of course, there will be slight differences if you expect it to be in a peso value versus if it's in a British sterling value. Then you have your customer ID. Yeah. And then country. So here's another one, like country. So it's also important to know what's like for terms like as vague as country, you have to know what they're referring to. For example, this one, if you say if you look at the data frame and you just look at country, you might like think na, oh, this is the country of transaction, 'di ba? Parang dito ginawa yung dito binili, 'di ba? Kasi it's a transactional database eh. So you might have that thinking, 'di ba? Na parang the country might be referring to the transactions. But in this case, that's not the case, right? Like as if you look at the data dictionary, it turns out that your customer ID refers to your customer ID refers your country name, I mean, refers to where your customer resides. So that already changes, like makes a huge change in how already makes a huge change in like how things like how you interpret your analysis. And then here we have another here you have another days for days bought, which is the number of days prior to that the day given, which is September 12th, I think, or 2011. There. So that was the last day that it was bought. Because I think this is a somewhat old data set. All right. So here we have another code that just to check in info. So this one can give you a quick overview of your data set. So you can see here already the how big your data set is. So you have 541,909 rows. But then here you can see that there are some columns that are not the same. That does not have the same value, such as this one. The description, it's 500,040 and 455, as well as the customer ID na ano lang, nasa 400,000 lang. So from there, you already know that, oh, there's some kind of cleaning or there's some kind of, it's not a very clean data set, or like there's some discrepancy in the data set kasi all the rows are not the same. And even there's also some things that you might be particular with, like invoice number as object, that makes sense kasi di ba parang it's a unique value. But you kind of notice here that your customer ID, which will also be unique, di ba? Kasi customer ID parang yung student number mo, di ba? Hindi naman siya, hindi mo pwede add yung student number mo sa yung student number ng katabi mo. And it's definitely not a float. Di ba? Floats are decimals. So you know there's that this is not a correct data type. So just by looking at .info, you can already infer a lot of things that you need to probably check with your data set. Okay, which we will be going through in the next portion. So the next part here is data preparation. So data preparation, as I mentioned a while ago, it's ensuring that data is clean. So if you recall kanina, we've mentioned missing data, illogical data, outliers, all of those things. Okay. So the first step in the data science process, the first step in the data preparation process, I mean here particularly, is to check the integrity of your data. So remember, data science, if you recall the image a while ago, diba, it's you feeding your data and then the machine giving you an output. So it's very important that here it's garbage in, garbage out. If you feed you can feed your model dirty data, but if you feed your model dirty data, then it will give you useless results, right? Garbage in, garbage out. So you have to make sure that what you're feeding your model makes sense. It's clean, like kasi sometimes if you just focus on the results, yun nga, parang it might not be applicable, it might not be replicable. That's another thing, diba? You might get lucky sometimes, you get good accuracy, but the next time you do so, it's not gonna be the same case because maybe the data that you did wasn't really replicable. So you have to make sure that your data is clean. Parang kasi nga garbage, just keep that in mind always when working with machine learning projects, garbage in, garbage out. Okay, so missing data. So to check missing data, again, using Pandas, it's kind of straightforward. You just go is NA for like, is it a missing value? and then you can go dot sum to count how many missing values there are. Kasi by Pandas syntax, if you check the missing value using this, there you get like a data frame whether it's true or false. So if it's missing, then it's true. If it's not missing, then it's false. But of course, that's hard to read, right? It's hard for us to get any information out of that. So that's why we sum it up here. There. So when we have missing values, the next question in mind there is, so what do we do next, right? Do we drop it? Do we impute? Impute meaning like we add another value, a possible value to it. So how do we handle it? Or do we simply um like go back to the data source? So sometimes that's an option, when you're handling with data that are very particular. Sometimes you even have to collaborate with your data collectors, your data engineers, to ask them why are there missing values, especially if there's a lot. Like if imagine like if you have like 50% of your like a column is missing, then you can probably confirm with like data engineers and or your data collectors like what happened, because maybe it can be mitigated. Maybe you don't have to be working with that dirty data. So that's the time when data science becomes a collaborative process. And at the same time, even in your company, they will probably like see you as a better data scientist that way, because you're not just focusing on like, okay, this is what's given to me. Ito lang yung gagawin ko, right? With that case, they see that you actually look at things end to end. So you actually benefit also the other people in the team, kasi nga you're giving them feedback also na, oh, maybe we can improve our data collection process kasi I noticed that there's this much errors going on. So it gives you a higher value in your company. You become a more important player, because you're not just like crunching numbers mindlessly. You're being mindful of what you're doing. Okay. So, but of course, it's like a case-to-case basis. Of course, if you only have like 5 or maybe even like a not so significant amounts of error, then it makes sense to drop it, right? Like, I mean, you don't want to like bother everyone if it's like something that is not that will not really affect the final outcome. Okay, so here we can see that in our data frame, we have for 541,909. And then if we drop all the missing values, we get 406,791. So not that bad, given that you still have a lot of data to work with. But let's look at the other option, which is basically imputing data. So let's look at the other option. Yeah, so I just made another a copy of the data set and renamed it to an impute variable. So the reason I made a copy so that we don't so that if ever we have to revert back to the original, we don't have to worry. Okay. So what should we impute? So here, this is your first introduction in this lecture, at least, to Matplotlib. So Matplotlib, as I've mentioned, is a visualization tool. So it gives you the ability to plot things within the same notebook. So plotting it, like, it's really very straightforward here. The ones that I'm currently highlighting is the main code. So this is the main code. It works as PLT. And then here, what kind of plot you're trying to do. So this can be bar plot, line plot. For this one, it's a histogram. So if you guys are not familiar, histogram is similar to a bar chart, but it's not a bar chart. Because a bar chart usually is like a classification. It's like you have, like, for example, male, female, or like colors, red, blue, green, and how many people are in that classification. Diba? That's how bar charts work. Diba? For histograms, it's more on the distribution. So you have your values there, and then how many items fall within that range of values. So for example, in this case, as you can see, probably somewhere between 0 to around 5,000. Yeah, I think around 5,000 or maybe even less. You have over 50,000 of your data set. So 50,000 of your entries are within that range of values. But the reason here that you can see negative 10,000 all the way to 40,000, because it means that there's values there. There's still items there. Kasi kung hindi, Matplotlib will not plot it. if there's no values there. So it's just so happened that our range is from 0 to 500,000. So that's why the value there are probably very small that you cannot see them right now. So here, just going back, this is the syntax just to share with you guys to make sure that you understand the code. So this is the syntax for plotting. So this is, as I mentioned, this one in the middle is the plt.his is like your main code for creating a plot. And how it works is you're just telling them which um, column you want to call out. So yeah, I think I skipped this part for pandas. So if you want to specify a specific column in pandas, you just type the data frame name, which in this case is data frame underscore retail underscore impute, and then the column name in brackets. So we have this column name a while ago, unit price. So this is how you select data with pandas. Okay. And then all of the rest, this like plt.figure equals fig size. This one is used just to fix the size of your figure. Para it's more it can be seen easier. So it becomes an 8x6 figure. And then for the title here, I just added this because I'm kind of OC that I don't like charts without labels, and I highly encourage all of you guys to do the same. Like as much as possible, don't have charts without labels. So like this one, then you know that it's the distribution of unit price. So here, so this is how we plot using Matplotlib. This is a common syntax, and there's a lot of other features that you can add. So you can add, like for example, here you can have like X label, and then the name of your labels. I think in this case it's amount. Smiling. Like amount. Let's run. There, see, so now you have your X label there. You can also put like Y label, etc. So all of these you can check within the documentation of Matplotlib. Okay, so yeah, as I mentioned, if you look at this carefully, this is actually a data set. So it actually has values at the extremes. It just didn't show it a while ago because probably since because the values are too small. But we can zoom in by again providing the argument. So like for this one, if we adjust your Y limit, so you have your X axis, right, and then your Y axis. So if your previous Y limit is around 500,000, well in this case it became 400,000. But yeah, so this one, so you can like adjust the limit so that it would zoom in. So like right now, instead of going all the way to hundreds of thousands, it's just up to 100. And in that way, you can already see that there are values at the extremes, at the negative 10,000 and 40,000 here that wasn't visible a while ago. So like if you really just want to zoom in, you can adjust your axis. Okay, so why am I showing you the distribution? And again, for those people who are asking a while ago about statistics, like, why is this important? You know, so one of the reasons why we look at we want to see the distribution is because we want to know how to handle outliers. So these are outlier data, diba? They're far beyond. Or one way is also to know like how do we impute. So problem with having outliers is that if you use the mean, if you're familiar with your measures of central tendency, right, you have your mean, your median, and your mode. So your mean is just like the average, the usual that we use. So like if you're computing your grades, you add everything and then you divide it by the parang total. That's your mean, right? If you're like computing grades for the number of students. Median is the middle value. Median. So basically, if you're computing for the median, then you just arrange all of your students and like get all of their grades and arrange them in smallest to highest, and then literally get the middle value. That's your median. And then your mode, of course, is the most frequently occurring one. So for example, if you have students that their grade is like 70, 70, 89, 90, 99, since you have 270, that's your mode. So those are your measures of central tendency. So when using mean, the problem with mean is that it's very susceptible to outliers kasi nga it's the average of your total. So for example, if you're working with monetary data, such as this one, it's price, so it's pera. You will have outliers. You will have people who are spending so big, and your mean you would be skewed to that one. Diba? Yung parang it would move it will become higher kasi it's taking into account the outliers. Compared to medians, it's positional. Diba? It's just like the one in the middle, regardless of what the values are, then it's not as susceptible to outliers. So if we check here, for example, if we just like check the mean by just using dot mean, and also the median by like using dot median, then we can see here that the mean is actually 4.6, but the median is lower at 2.0. So this is just like an example showing that it is different. It's not exactly the same. So how do you know which ones to use? Right? So most of the time, if you have outliers, it's better to use the median. All the other times, it usually doesn't make that much difference. So again, going back to Python syntax, if you want to fill the missing values, you can just type fill NA, and then with the value that you need. So that's how this code works. Fill NA and then the value. Okay. So as you've noticed a while ago, our unit price has a missing value of 57. But this one, it since we imputed the missing value for the unit price is now 0. Okay. So this is a very academic example because you only have 57 missing values. So obviously, like it's not gonna make that big of a difference. So for example, if you just drop them, then your new descriptive stats becomes like your new count would be 406,791. Your new mean would be 3.460618. If you impute, then it would be you would have slightly more observation, 406,829, and then your mean would be 3.460489. So the difference is very small, particularly because for this case, it's not you only have 57 missing values. But what the point I'm trying to drive at here is that you cannot like assume what to use for handling missing data, especially if there are more. Like in this case, it just so happens that it's very small. It's 57, so it's really not gonna make a big difference. But in cases when you have like 100,000 of missing data, you have to be careful how you work with it. Like if you drop it or impute it, and that's like just the point that I'm trying to drive at here. Yes. And again, syntax wise, if you want to see the descriptive stats for your data set, just type in df.describe, and it would automatically give you the descriptive statistics for all of your numerical values. So as mentioned a while ago, like for customer ID, it doesn't make sense because it's supposed to be not a numerical, like it's numbers, where it's supposed to be like a string or a unique value. Pero since we haven't addressed it yet, it included it back because it's really okay. So having said that, we can proceed to the next part, which is correcting data types. So yun nga. So we know, as I've mentioned already, that customer ID should not be a float. Like it doesn't make sense. Imagine your student ID, diba? It doesn't make sense that your student ID has decimals or that you do computations with it. So it's very simple. Like typecasting in Python and in Pandas is very simple. You just type as type. So to change the type, you just type as type and then the type that you're looking for. So if either it's integer or float, so in this case it's a string. So you can just go again to specify that particular column, just type in the data frame name, your column name, and then the value, what you want to do, which in this case is to convert it to string. Okay. So here, and then we assign it back to the original column para it overwrites. Okay, so checking again the data set, you can see here now that the customer ID is now an object. Meaning, so in Pandas, objects are either string or it can be mixed values. So in case that you have like numbers and strings in the same data frame, in the same column, then it would still result into an object. Pero yeah, so at least you know here that it's not anymore read as purely numerical. Okay, and then checking here. Yeah, so checking here like the data frame. So it's now a string, pero it's a string with decimals, and that's fine when you think about it. It wouldn't really change your computations. It's just zero and all that. But just being OC, just being just wanting to like clean things further, you can just like do dot replace. So this is just string method. I know most of you are already familiar with Python syntax, right? So this is a Python syntax of replacing strings. So you can just replace strings by doing you can just replace 0.0 with a blank. Mhm. There, para lang it's clean. And just to make things easier later on, like I just copied it again to a new data frame, which is our final data frame. Parang we know now that this is our clean data frame that we can use. Okay, so now we have our data frame, which has like our invoice numbers, our stock code, description, quantity, date, price, customer ID, country, and date/bot. And we're assuming that this is kind of clean, like we're assuming that this is clean already. There's no missing value to those that matters. Like there's still missing values, I think, for descriptions, but it doesn't. But that one's fine because we're looking for RFM and like if we're looking for recency, frequency, and monetary value, like description isn't really that big of a that doesn't really a big of a factor compared to the rest. Okay. So yeah, so next we have, so now that we have that, then we have to engineer our features. So I always find this funny because like feature engineering sounds like a very fancy term, but it's actually just another term for like creating features, which is features guys just your column. So in a way, sometimes it's really just like making new columns. You can think of it that way. Like it's such a fancy term, feature engineering, but you can also think of it like making new columns or like making new variables to feed into your data set. Okay, so for this case, we're focusing on RFM. So we have three things that we need, right? Our recency, our frequency, and monetary value. So those are the three things that we want for our like data set to feed in our model. So let's begin with monetary value. So monetary value, as the name implies, how much money does a customer spend on purchases? Okay, so to do that, so we already have a final data frame, right? Retail final, and then here we have our unit price, right? We have our unit price and we also have our quantity. So if you recall, your unit price is per unit kasi kaya nga siya unit price, right? So it's for per item. So if you have your quantity, then it's logical to multiply your quantity to your unit price to identify ano yung final amount that was paid by that transaction. So like for example, you bought one egg cost like 5 pesos, you bought 5, and then you goes 5 times 5, right? To be your total amount. So basic math. And in pandas, if ever you need to form a new variable column, then you just make your data frame name and in brackets the name of your new variable. This one automatically creates a new column. So if you have this data frame, it would automatically create a new column amount that contains the values that you supplied, which in this case is quantity times price. Okay. So, what was the last one? Sige, let's try. All right. So now that we have our data set with that, we want to do group by. So group by is a way of aggregating data. So currently, our data set, itong retail final, it's per transaction, meaning one row is one transaction. So like, for example, you went to, say, I don't know, 7-Eleven today, and then so your customer, let's say your customer ID 101. So today you have you have one entry. And then tomorrow you go again to 7-Eleven, you have another entry. So your customer ID is not unique. I mean, it has duplicates because every time you go there, every time you buy something, you get one row. Like that's how our data goes, right? So as you can see here for customer ID 17,850, dito pa lang in our head, we can see that there's already 5 transactions. Just by, I mean, it already like the first 5 transactions in our data set. So obviously there's duplicates per customer. But when we do our model, since we're trying to do customer segmentation, we want every point in our model to be one customer. So we don't want duplicates for our customer ID, right? Because we want every we're clustering our customers. So we want for every customer, dapat there's only one row. So to do that, we have to aggregate values. So one way to do that is by using the syntax group by. So for example, in this case, we group by, and then here in parentheses, how group by works is here in parentheses, it shows you which column you will be forming the clusters or the groups. So in this case, since what we want is to group them by customer ID, like we want to know like the total amount. So like for example, you as a customer, just like in a span of let's say 1 year, how much did you spend all in 7-Eleven? Okay, that's what we're trying to answer. Like how much did you spend as a customer overall in this store? So to do that, we like specify that you're the customer, we'll group by customer. And then what are we trying to look for? In this case, it's the amount. And then how are we going to aggregate it? Obviously, since we're looking for your total amount you spend, then we have to use sum. Diba? Depends on the, like in some cases, if you're looking for something else, it might be the mean, it might be the maximum. So it depends. But in this case, since we're looking at the total amount that you're trying to that you spent, then it makes sense to use sum. And again, this is how the group by syntax works for pandas. Then we assign that to then we now assign that to a variable, which is our RFM_M, so like short for monetary. There. And then here is set index is just a way because if you do group by, automatically the one in parentheses becomes your new index. So this one becomes your new index if you wanted it. But if you do group by, then if you do reset index, then it goes back to being a column, and then the index becomes a chronological number, a chronological order of numbers. So here, so now for this, you can expect that there's no more duplicates for customer ID. So every customer ID is one value and each customer has an amount. So you have that already for your monetary value. So next step, we have our frequency, which is how often a customer makes a purchase. So we know that yung kanina nga, every row is a transactional row, right? As I mentioned, like one length is one transaction. So we can simply count how many rows there are per customers to know how frequent a transaction is. Diba? Kasi if pumunta ako, tapos like, lumabas ako, tapos for example, may bumili ako ulit, that's already 2 transactions. Right? Like, may nakalimutan ako, bumili ako ulit. That's 2 transactions again. And then we want to count how many transactions you have. So same syntax as a while ago, group by customer ID. But instead of amount, we will just use invoice number. Kasi like, we're assuming that one invoice number is one transaction. Like it's the unique one in our former data set. And then we simply use dot count. So dot count is literally just counting the number of rows. So you want to count how many that we have for each customer ID, and that would give us our frequency. Here. And then here, this is just a syntax to rename column name. Because when you use dot count, it doesn't give a column name for the result, so you can rename it to frequency. Okay, then third here we have recency. So recency is based on how recently a customer has made a purchase. So in this case, we already have our end date, and we already have a column that like specify the days last bought. So to get the recency, same again, you just group by customer ID, then get the days last bought. And then in this case, we want the minimum value. Why? What's the logic behind that? Because like if I bought yesterday, then the days that I last bought is 1 day ago, right? And then if I bought like 2 days ago and all that, so the most recent one is the smallest value. Because if I bought yesterday, compared to 2 days ago, mas recent yung yesterday. So that's 1 is lower than 2. So that's how recency works. So you're getting the minimum value among the days that it was bought. There. So now we have our recency. Okay, so now that we have all 3 things that we need, recency, frequency, and monetary value, we just have to combine them all in one data frame. So in this case, yeah, we just combine them all in one data frame. So to do that, we just do pd.merge. So we can just merge them using pd.merge. This would, the first one would merge the first 2, monetary and frequency. I'm sure most of you are familiar with SQL syntax. So yun nga, SQL syntax, how inner, kasi we want like the same customer ID, pero most likely like they would have the same unless kasi there's like no missing values for this. So like number of customers should probably be similar. There, so pd.merge, and then then you feed the data frame that you need, which in this case is the RFM plus the recency. So we add that more. Then we get now our data frame that is a lot smaller than our original one. Our original one is around 500,000 by 9. Now it's just 4,372 by 4. So that's the number of customers that probably went to this store. And here, we already have here like an initial data frame of our RFM, which will later feed in our model. Okay, so one thing that you have noticed is that we were working with amount, right? Money. And the thing I mentioned, the moment you start working with money, most of the time, more often than not, there will be outliers. There will always be extreme values by like people who like spend so much or yeah. So here, one way to visualize outlier, or it's my favorite way to visualize outlier, is by the use of box plot. So here, this is now a different plotting technique. A while ago, we used Matplotlib. Now we're using Seaborn. And the syntax is still very similar. You just type in Seaborn, SNS, dot, and then the plot that you're trying to do, which in this case is box plot. Tapos like, and then within it, like the data that you're trying to plot, which here is our RFM data minus the customer ID. Kasi we don't need to anonymize the customer ID. Like we don't need to get its distribution. It's like it's just number of terms. So we just want to see the distribution of the amount, frequency, and recency. So you can see that frequency and recency are somewhat like just a small range. Where for amount, it really goes beyond. Somebody spent more than 250,000, and then their total transactions. There. So how do you handle this? Like now that we have outliers, because why is it important in the first place to work with outliers? So one reason why is because we want to outliers can really affect your models, given that your models work in, imagine that a scatter plot, diba? Like when you're plotting, imagine like when you're modeling, always imagine that there are points in a plane, there are points in an n-dimensional plane. So if you're plotting this and you have outliers, then and you're working with distance, which most models do work with distance, like Euclidean distance, then if you have outliers, then definitely your distance would like explode. You know, there will be points that are very far that can really screw your models. So that's why we try to avoid having outliers. Unless that's really like unless there's really cases wherein it's better for models to still be able to absorb that. But in most cases, like it's kind of makes sense to just remove the outliers. So how do we remove outliers? First of all, we have to identify what is an outlier. So by statistics, like outliers are actually classified as those beyond the 1.5 times interquartile range. Sorry. Okay, box plot 101. Anyway, yes. So if you're familiar with the box plot, everything within like the 25th to the 75th quantile or your interquartile range, it contains 50% of your data set already because it's from the 25th to the 75th quantile. Then everything And then like outside that, you have your minimum and maximum. That's like how box plots work. And then if you go like 1.5 times that range, then that can be classified as your outliers. So in this case, we're checking for outliers for each, for the amount, the recency, and frequency using that formula. So like everything beyond Q1, which is our first quantile, and Q3, which is our 75th percentile. So anything that's beyond those two are your outliers. Well, at least 1.5 are interquartiles beyond those two. Yes, yeah. Apologies, like I don't have a better visual for box plot to show. Sana. But yeah, but the logic here is basically just we're just trying to remove um outliers using this formula and by just applying a Boolean syntax. So here recall that this is how we filter. Like a while ago, we were filtering using column names. But here we can, if you specify a certain range like greater than or equal to, then it uses your Boolean logic to filter. I'm sure like as most of you are computer scientists, you're familiar with like the Boolean logic of you, like true, false, all of those things. And as I mentioned, like the interquartile range is between your Q3 and your Q1, which is between your 75th and your 25th percentile. Okay, so with this, you now know that your outliers with this line of code. You can now assume that your outliers have been dropped. So the next step now is we have our scaling. So even if you don't have outliers, you still have different scales. Because if you're working with amount, even if you drop the outliers, that would still be in thousands, right? You can still have thousands of pesos. That's still like within normal range, not outlier range. You would still have thousands of pesos. Compared to recency. Like recency is probably just malaki na yung 365. It's like that's like 1 year, right? So even if you're 2 years, that's like 300. So it's not gonna reach the thousands. So you have different scales. Yeah, so you have different scales that you're using for them. And again, that affects like when we're using this as our features and plotting this in points and n-dimensional planes, that affects like your distance and how things relate to one another. So it makes sense for us to scale them in such a way that it's more comparable to each other. So one way for us to scale is by using standard scaler. So standard scaler is a way of reducing everything to the number of standard deviation that the value is from the mean. So again, more statistical terms, standard, familiar with standard deviation, right? It's like the variant, that's like the what's that variance squared. No, it's like the square root of your variance. Yeah, so now if you have your standard deviation, you want to see now like you want to reduce that. Yeah, you want to standardize, like you want to reduce the scale of your data set by reducing everything to the number of standard deviation. Okay, and to do that, this is our first time using our scikit-learn. So scikit-learn is a package in Python that has a lot of tools that you will be needing for your machine learning process. So if you've already ventured in some of the codes in ML, you would probably have noticed already scikit. You've probably encountered this already since it really is it's very useful. Like it's one of the most popular machine learning libraries out there because it has a lot of algorithms, like it has a lot of classification, supervised, unsupervised, regression, and then it also has a lot of pre-processing tools that can help you with that, such as scaling. It has ways to impute. It's a very powerful library, and really very thankful for people who are maintaining the scikit-learn library. All right. So to import the scaler, you just go to scikit-learn sklearn.preprocessing import standard scaler, and then you already have that. So you already have your so once you have your scaler, all you have to do is to fit and transform your data set to it. So fit basically, if you have a scaler or any like if you have like any imagine there's like you have a template and then you want to fit something on that template. And then transform is basically like telling you that your data set should like how you call that, like literally transform, like change to fit that data set. So that's how fit transform works there. So now we have our scaled data set. So here we can compare a histogram. Again, we're checking the distribution. So we can compare here the histogram of our original data set. So this one is the one that is not scaled. So we can see here, this is a not scaled one. So histogram here, this one is just a code for so that they'll be side by side. Axis equals 0, 1, 2. Yeah. And here, this one, PLT subplot, just tells you that you want 3 plots in one figure. Kasi diba normally we have like one plot in one figure. But in this case, like to make it easier to see, we just given the code like plt.subplot, and then like specify here number of rows, number of columns, and then here they just specify that each entry should be fed into that axis, which is this one. The first axis is the amount. I mean, the 0 axis is the amount. Axis 1 is frequency, and axis 2 is recency. There. So you can see here. And once we scaled, we can see that it's like we can see that now the our a while ago, if you notice your x-axis here without scaling, it's from for your amount, it's from negative 5,000 all the way to well, it's like 12,500. Here it's from 0 to 700. Here it's from 0 to around 400. So you have different scales for your points. In this case, after applying standard scalar, it's all now just within less than 10. So you have negative 2 to 6, you have negative 1 to 6, you have negative 2 to around 4. So now it's more comparable, if you've noticed. Like, but then the actual distribution didn't change. It's still the same, but at least the scale wherein the points are. So now, like, imagine that you're like put them all in one graph wherein there's like you're in a scatter plot. It's now easier to plot it since your axis, your x, y, and z axis are only between negative 2 and probably 8, like 7 or 6, right? So it's like it would make more sense while you're clustering. Okay, so all of these are pre-processing steps. So that's a lot. I mean, I know it's a lot of info already. I hope you guys are still doing okay. So all of these are pre-processing steps to prepare your model, to prepare your data set for modeling. So we, if you recall what we did, we remove, just a quick recap. What we did is we remove missing values, and then we corrected the data type so that since the customer ID is very important in this data set, since we're clustering by customers, and then we are able to create new features, like to be able to feed our RFM, right? So we created our features by doing group bys there. And then finally, once we have our features here, we remove the outliers so that we don't have extreme values. And then now we were able to scale so that it's all within like a similar in a comparable range. So those are common pre-processing techniques. So this is things that you will be encountering a lot if you're doing a machine learning project. You'll be doing a lot of feature engineering, a lot of scaling. By choosing which columns to use and not to use, that can also be called feature selection. Since again, as I've said, like data science is funny, it uses a lot of fancy term for simple things. So that's called feature selection. And then you also have here a lot. So in all of these things that you've been doing prior to modeling, you can classify that as what we call EDA, or the exploratory data analysis. Because basically it gives you an intuition of your data. Like you're exploring your data set, trying to find, checking its integrity. Is it like a useful data set? Like, and then try to check like the values, like does it make sense? So all of these fall under the classification of EDA, or exploratory data analysis. And that's usually a step that you do prior to modeling. Okay, so now we're at our second to the last part, which is modeling. So it's been a long notebook. So now we're ready. No more missing values. There are no strings. Features have been engineered and selected. We can begin modeling. So again, for this one, we'll just be introducing you to a very simple model called K-means. If you recall a while ago, I explained how it works. So how K-means work is basically you're using a centroid, it's a centroid-based clustering. So it uses centroids, like centers. And from that, it's just trying to find which how do you position the centers in such a way that the clusters have the similar clusters are together, and then they're farthest apart from those that are different from them. So this is like the main intuition behind K-means. If you like, we're not going to go through all of the math as like how it actually computed, but at least be familiar with the intuition of how it works. Okay, all right. So again, our favorite machine learning package, scikit-learn. So you can just import k-means by doing from sklearn.cluster import k-means. Simple as that. That's how straightforward we import algorithms. Okay, and then while we have k-means, we then identify our parameters. So this is called hyperparameter tuning. So every model have its hyperparameters, which are like values that you assign to like improve your model performance. So for this case, one thing about k-means is that we set the number of clusters. Like we are the ones who declare the number of cluster that it's going to use. So that would depend on our analysis and our need. So in this case, for example, let's say that we want 4 clusters. So we can just put here n clusters equals 4. And then max iter is just where for how many iterations. So like again, as mentioned a while ago, the changing of the centroids and then the changing of the points is done in iteration. It is done again and again. So max iter just says like how many iterations do you control the maximum iterations so that it before it stops. So by default here, again, we have the default values. So the number of clusters by default is 8 if you don't add anything. And then here are other values. So it's just max iter equals 300, all of those things. And again, these are called hyperparameters since these are the ones that you tune. These are the ones that you change to improve your model performance. Okay. And then once you have your model, so this is how you declare model, then you assign that to variable. Once you have your model, then you simply fit your data to it. So this is actually, in terms of unsupervised modeling, this step is actually already called, it's already the training portion. So this is like already training your data set by fitting it into your model. And then once you have that, once you're able to fit, you're able to predict. Now you can predict which cluster it belongs to. So here, very simple, in 3 lines of code, you're able to do a machine learning model, right? This is actually already a model, but how well does it perform? That we don't know yet, right? But then here in itself, you're actually able to do a clustering model in just 3 lines of code. Okay, so model performance, as I've mentioned, unsupervised modeling is quite tricky because you don't have a gold standard. You don't have like that accuracy score or that margin of error that you're trying to avoid or that accuracy that you're trying to reach. So you don't have those things. So you have other things to check. So one thing that we want that is very important in k-means is setting the number of clusters. Kasi nga, the clusters is defined by us. The clusters is we choose which clusters. So one way to determine the number of clusters you're going to use is by using the elbow curve method. So how the elbow curve method works is that you simply try running the model. So I'm sure you guys are familiar with looping, right? So you just try running the method again and again. So again, this is your line of code. You just do it again and again, and then append the results. And then for each result, you will compute the inertia. So inertia is basically the sum of squared differences. So this is sum of squared differences is like the way to calculate how closely related your clusters are to each other. So that's like the the higher the inner, so the more related they are to each other. Yeah. There. So we can see here, one way to use the elbow method is by checking where the elbow is. So it's literally like an elbow. So which point has the sharpest curve? That is usually the cluster that you want to use. However, in some cases, of course, it's not as intuitive. Like for example, this one, the elbow is at 1, but of course, it doesn't make sense when you're clustering. Like you don't want to one cluster, so you have to sometimes make trade-offs between like your need and the math. So like for this case, like it gives you an elbow of 1, pero it's not aligned with your need. Like you don't really want to just have one cluster, so you might have to adjust it to the next possible elbow, like 2 or probably or maybe even more. So ultimately, yeah, again, it depends. That's the problem with unsupervised machine learning. Ultimately, it depends on like how applicable it is to your business, because like that's like the measure of success for unsupervised machine learning. Does your clusters make sense? Later on, that's how you know if it's like a successful clustering model. Okay, so we discussed about the elbow method. Now we will go to the silhouette. So silhouette method. So there's another way to check if your the number of clusters that you should provide is by the silhouette method. So again, we just import from sklearn.metrics, import silhouette underscore score. So again, you just iterate again and again, predict. Here, you just make an iteration of your k-means. You just loop it in within the value, the cluster that you're trying to test, which in this case is a range of 2 to 8. And from there, by using the silhouette score that you imported, so here's silhouette scored, and then your data set and your labels, you can check the value of it would like automatically provide you the value of the silhouette coefficient already. So here, in this case, it shows that from 2 to 8, the silhouette score is decreasing, which is similar to what we could have seen in the elbow curve, that like 2 is still the best. Like here, you can see that the higher the silhouette score is actually the saying that the higher the silhouette score, um, the higher the silhouette score, like the closer, the more similar clusters are together. Yeah, the more similar they are together and the more different they are from neighboring clusters. So we want a high silhouette score. That's usually, and it's a value between 0 to 1. So we want one that is close to 1. So in this case, we can see that as similar to the elbow curve, like 2 is probably the ideal cluster. And but you have other values here as well. All right. Yeah. Ironically, like I've been saying that 2 is like the ideal cluster, but then as I mentioned, like it depends on your case. So it also like it's kind of not like similar to having one cluster. It's also like not that intuitive to have 2 clusters. So that's the time where then you have to check your trade-offs, like which silhouette score is acceptable for you. So those are the things that you can question or like you can ask yourself. So in this case, you can say that, oh, a 0.5 is still like relatively good for me. So I'm good with using 3. Pero like 4 is probably not. So like these would be already things that you talk to as a team or as a like or like with your stakeholders, like which values is like acceptable for you. So these are things that you already collaborate with the people you work with, so that you can like know that like and similar with like accuracy for classification. Like you have to like coordinate like which is an acceptable value for us, right? Which one is to say, because it's not, there's really no one value that we can say is good. It depends on our use cases. Okay, so yeah, so similar to a while ago, now like we have decided to cluster. At least for this case, I just like for the sake of example. So this is like really just for the sake of example. Let's say that I'm okay with the silhouette score of 0.5, and then so I'm okay with having 3 clusters. So there. So like these are my clusters. So let's do one. So in this case, let's use a random state, which is you guys are programmers, you know why we got 42. So there. Let's use a random state para at this point onwards when we model. Kasi syempre, from here, if you observe, you probably didn't, oh wait, this one also has a random state. But for this one, you probably didn't have the exact same results or the exact same values. Kasi your model will not be exactly the same all the time. You're training it, so it can have differences. So one way to ensure replicability is by giving a random state. So in this case, we have a random state. Let's just give a random state of 42 so that when we answer the exercises later on, we're all aligned with our output. Okay, so again, as mentioned, this is like our quick modeling code. So just k-means cluster 30. Let's try iter 50 in this interest of like just so that it doesn't the higher the iteration, like the longer the model takes to run. So right now, for the sake of demonstration, we can limit it to 50 and then random state 42, just so that we all get the same output. There. So now we fit the data set, and then here we get the labels. All right. So now we have our labels with this label column. We can now create a new column in our data frame, in our RFM data frame with the cluster that it identifies with. So since we use n cluster equals 3, so we have clusters 0, 1, and 2, right? So we have 3 clusters. So in this case, there, so you can see here that every customer is assigned to a cluster. And as I've mentioned a while ago, for k-means clustering, you can only be assigned to one cluster. So there's no multi-assignment for k-means clustering. So you're only assigned to one of the clusters that we've identified. Okay, so now we're at the last step, which is evaluation. So this is our last step, and so this our last step is basically trying to see if our class makes sense. So one way to evaluate unsupervised machine learning results is by visualizing it. Like we can visualize our output. So to do that, let's go to like similar to what we did a while ago, like doing our box plots to see the distribution of our results. So here we just did RFM, cluster ID for our x-axis, and then Y is the recency. Then here Y is the frequency, and then Y is the amount. Then all of our cluster axis is cluster ID is 0, 1, 2, 3. And then you have here 3 box plots for it. So that's why you have axis 0, 1, 2. Okay, so here we can see that it indeed was able to find a way to cluster. So like for example, let's look at cluster 1, like the middle cluster. We know that cluster 1 in this case are those that are probably the least, like yung matagal nang hindi bumabalik. They're probably the ones that are like, some people are more than 350 days. So they're like probably a year ago. Some of them are more than 100 days. So there's already a lot of, it's already a long time since they visit. So it hasn't been that recent. Also with their frequency, like it's also quite low. It's the lowest among the rest. So if you look at the interquarter range, so the interquarter range I was referring to a while ago is this box. Can you see my cursor? Anyway, yeah, it's this box, the interquartile range that I was referring to. So that's where you can say that like 50% of your data lies. So here we can see that like most of our data for frequency is low, right? It's like less than 100 or even less than 50 if you just look at the interquartile range. So from that, we can already have intuition that cluster 1 are those that visited a few times a long time ago. So they're probably not your regular customers kasi bihira lang sila visit tapos matagal na. Yung mga ganun. So they're probably not your regular customers. They're not the ones that you're most attracted with. And then you can also notice that from but in terms of monetary, so you can see that there's a huge range. It's like, I am not sure your negative values. It's probably like refunds or something up to 5,000. So given that, you can really see that huge range within cluster 1. You can probably assume that it's because really they're just random people who are passing by like a long time ago, and there's probably like very different spending habits because it's not like it's not like your regular customers. That's why there's probably a variation in their spending habits. So just like by looking at this, you can already create a persona of our idea of like, oh, who are these customers? So yun nga, as I mentioned, cluster 1 is probably someone like that. Cluster 0, if you look at it, it's a very wide frequency. So these are people from that either often come or comes once. Very one thing that you can notice for cluster 0 are they're the ones who spend a lot. Like their entire quarter range, if you're looking at it, or at least even your median value. So the line in the middle is your median value. So if you look at the median value, these are the people who spend at least 3,000 already, like 3,000 sterling. So that's a high amount of money. Like it's the highest median value among the rest. So, like from a marketing perspective, you might be thinking already, oh, these are probably people that um I want to come more frequently. So maybe this one, the lower tail of your frequency, you want to push that higher. Probably you like to want to push it higher, similar to monetary, because these are people who spend, right? So you already have those strategies in place that are data driven based on your data. Right? So yeah, so just by looking at this data set, just by looking at these clusters, and it's a very simple exercise that we did. We just did RFM, and then we just did a very simple model. Our model isn't probably not even like optimal yet. It's just like it's like an introductory model. Or even with that, you can already have this intuition, and you can already make data-driven ideas on like what are your personas, what are the type of what are your possible recommendations for it, with a very simple exercise that we did in like 2 hours. So yeah, so it's like I hope with that you are able to appreciate this activity. Yeah, I hope you're able to appreciate this activity. Right now, I know we have a lot of time left, but um this you have an exercise. The organizers asked me to give you guys exercises to practice with, so you can practice with right now. Like you can check what is the median recency of cluster 1. So we've noticed that cluster 1 has the highest median, so you can check what is the median recency. So for this one, you can like practice your Pandas skills. How do you get median for a data frame? You can also check like what is the largest range of values, which cluster has the largest range of values, and what is the range. I think when you say value, this is monetary value. So look at the monetary value. Does cluster 0 or cluster 1 have a larger range? It's actually not that easy to eyeball, kasi parang cluster 0 is from 1,000 to 13,000, pero you also have from negative to positive for cluster 1. So might be easier. I mean, you can try to check what is the range. And which cluster has the most number of customers. So that's also one, because like here we haven't checked it yet, pero these are not equal. Like your data set, like right now we have 4,000, right? That's not divided by 3. It can be skewed. There can be a data set spreading 2,000, half of it is one cluster, half of it is, and then like 1/4 on the others. So it's not evenly distributed. So it's also a good way to check if your clustering makes sense. Because if it's super skewed to one cluster, then there's probably you probably need to tune your model more. So you have to check like how many entries do you have? How many like how many rows or how many customers are there per cluster. So that's one thing that I want you guys to check. And here are just some other questions for you to answer, like when performing clustering, what is K-means trying to minimize? In RFM, what refers to a customer makes a purchase? So here are just some other exercises for you to try on. And yes, so that's actually the end of our walkthrough. And I hope with this, you guys are able to gain an appreciation of data science, particularly unsupervised machine learning. And if there's one thing this notebook is also trying to share with you is that it's doable. Like we did a very simple machine learning project in less than 2 hours. So imagine what more you can do like in a longer period of time. So like this, I hope at least you like, especially for those who are asking questions about stat or math, like with this you can see that it's doable, and it also gives you like an idea of what are the things that you can improve on, or like what are the things that you can study on, because right now you probably, if you don't understand distribution yet, then you can like ask And you can probably like review those concepts. If you don't know how to read box plot, you can review those concepts, etc., etc. Okay. Yep, that's it for the lecture. Sorry, I haven't really been checking chat, so I'm only checking chat now. If it's okay with the organizers, I think we can proceed with Q&A.
Okay, thank you, Miss Julia. And Miss Julia, we have series of questions here in our chat box, on the Zoom chat box. So
Okay.
from, I think from Stephens Johnson Balo, what certain topics in statistics should we focus to study? Or is it until already?
Yes, yes, yes. I think yeah, I answered that already.
Okay, from Earl Ragutero. Would data engineering be a better precursor compared to data analytics when aiming to be a data scientist?
Yes and no. The thing kasi, data engineering and data science are two very separate fields, especially in very established companies. Kasi data scientists are the ones who are doing the analytics. They're the one doing like the ones we did. Like there's a lot of math involved, stat involved. So it involves those things na parang uh yung parang it's really like what do you do with the data once your data is in your hand. Data engineers are the ones preparing the data. They're the ones like doing the data warehousing, data lakes. Sometimes there's also like the cloud engineers, sometimes at parts of the data engineering team. So they're working more with SQL, to ensure that the data arrives at the end of the data scientists. So for small companies, this usually combines. Because if you're small companies, usually if you're the one working analyzing the data, sometimes you're also the one maintaining the database kung hindi naman malaki yung database. But for bigger companies, it's really a separate role kasi ang laki na nung database na mini-maintain nila. Diba? It's really a lot of different connections already. In terms of a precursor, it depends on like what your inclinations are. As data analytics usually is a better precursor to data science kasi data analytics covers your statistics. Data analytics usually involves your descriptive, diagnostic, predictive, and prescriptive statistics. So it gives you that analytical thinking that you need for data science. So if you want to be a hardcore data scientist or like yung mga true data scientist, maybe data analytics is the better route kasi nga data engineering is a different specialization in itself. So,
Okay, ma'am. And next is, what if the customer haven't bought anything before?
okay, all right. So this is a very good domain question. Like this is a very good question in terms of data understanding. So I encourage you guys to ask a lot of these kinds of questions. So it's two things. We didn't really look at it in depth, pero you can look at yung like on a customer level kasi we didn't like do intensive EDA, exploratory analysis, data analysis. Or you can look at it at the customer level. Tapos you can check how many of them have like a unit price of 0, like that. So I think here there's a customers that are unit amount 0. Pero this can either be kasi it can be either they didn't buy anything, that's why it's 0, or it can also be that kasi it's the median, right? So they could have a negative and a positive. So they could have had a transaction that it was canceled. So kaya din siya nag-0. So in that cases, I'm currently with the one how we computed it. It's taken into account. Kasi like with the sum, like it's taken into account. If it's negative and positive, it canceled out. Then like if assuming that negative is like parang refund, tapos positive is like the payment, then it would reach to 0. Tapos if it really not if it's not bought anything at all, and then tendency na it's possible that that means he doesn't have a transaction, which means that he's not part of the database. Kasi this is a transactional database. This assumes na probably linked to the company POS, yung point of sales system nila. So everything here is transactional. So you would see naman if there are discrepancies in your data set, like yun nga, if the unit price is 0, all of those things. So you really just have to check at the customer level, explore EDA at the customer levels, those kinds of like discrepancies. So thank you for that question, Child Andre. Next, we have how to distinguish if the model is overfitted or underfitted. Okay, so overfitting and underfitting is more often used in supervised machine learning. Because in supervised machine learning, we have yung measures like you have like accuracy and all that would when you say it's overfitted, normally it means that when you do your training data, like when you train your label data, you get high accuracy kasi nga parang it fits that one. Pero when you introduce new data that it hasn't seen, so for example, you give them a database of customers and then you have a label there like customer is good or bad or something like that, and then you suddenly a new customer comes in that is not there and you have that new set of data. If it's overfitted, it means the model is only fit for the ones that you have, the current data set that you have. So if you introduce new data, it cannot be able to predict it correctly, so the accuracy would dip. Parang when it comes to the new set of data, the accuracy wouldn't be nice, it wouldn't be good anymore, so it's not replicable. Underfitting naman is basically just having an underperforming data set. So when you have like low accuracy, yung mga performance metric, then it's probably underfitted. Yeah, pero normally these terms are used more for like supervised machine learning. Okay, are there more questions? I think here questions, data preparation still applicable to image processing. Can you give us a little idea how data preparation works on image data? Yes, so how image data works usually is that one way is that it works with pixels. So every pixel has a color, and then like every color is a layer. So that's usually how image are processed. Like for your image, imagine if you worked with Photoshop, it's kind of like how layering there works also. Like every ano is a color, and then every color has a point. So that's usually how it works. Data prep usually for big data, large data like that. One way to do it is like scaling it. Scaling in terms of not really the one we did, but more of like if you're familiar with PCA, principal component analysis. So when you have a large number of features, if you have multiple features, normally you want to minimize that into a fewer number of features. So one way you can do that is by doing data prep on like PCA, principal component analysis, to reduce the size of your features. So that is one of the examples of data prep that you do for image processing, and as well as other like even natural language processing when you're working with huge numbers of text. So yeah, those are other application of pre-processing when it's not like this usual CSV data frames that we're using for the more unstructured data sets. Thank you for that question. And you have another one. Apart from deriving insight for the business decision, like how we did earlier, are there other sample ways that the company can capitalize in productionizing the model you created? Company could capitalize in productionizing the model you created. Sometimes, so yes, so other ways, well, usually MM models can be a product in itself sometimes. So like one of the project I've worked with is, for example, they want to do a website wherein they want to tag their entries. I worked with a company before, or yeah, where then they have this set of articles, and then they want to be able to tag those, and then it's just basically too time consuming, one by human by people, and at the same time it's like a very technical topic. Like it's not a laymanized topic, it's a very specialized field. Sorry, NDA, I can't share that much info, but yeah, so we use NLP machine learning models to be able to automatically add tags to the data set, to their parang articles, to them, so that it's easier for people who are accessing, that they can visit, they can easily just like type in like what they need to look for. So for example, they want to look for like happy articles, and then it would like show up those kinds of things. So that's an example of like how, so in that case, like that's already the product of the company, that because they're offering like articles for access, and they're like having troubles of how to um they're having troubles and how to like being able so for how to their customers to be able to access their articles easily. So because we were able to tag their articles for them using machine learning, then then it really saved them a lot of time, and it allowed them to be able to offer a product that is unique to them. So that's one example. Um, yeah, there's a lot more use cases for machine learning. Business wise, there's a lot in terms of R&D, like in the R&D phase. But mostly it's a lot. It's mostly on like NLP, natural language processing. That's like very in right now, and also on classification models. Where classification models are usually specific to companies, like what are they trying to classify. There, some other interesting things also like topic modeling. If you're into like yung mga news, mga fake news, or like just yung mga like if you do web scraping and then you want to like identify what are the hot things that people are talking about, like on Twitter, then you can do topic modeling. So those are other examples of like things that companies are looking for. Like they want to know, oh, what are my customers talking about, right? So they can do like topic modeling of their of the tweets or the like reviews. There. Are there other questions?
Yes, ma'am. We have someone just preempt us, and the question is sending. If you weigh in, which is more important to you, model accuracy or model performance?
Oh, okay. So accuracy is actually a measure of performance. So when you say performance, kasi it's a group, like it's a umbrella term for all of the performance metrics of all of the different metrics. So like accuracy, and if you're like familiar with sensitivity, yung precision and recall, those kinds of things that like we look for. And so it's the same, but I think if you're asking more of like yeah, can you yeah, so that's one. If you're asking though for interpretability, as I mentioned, there's really no one answer. It depends on your use case, because as I've shared a while ago, like sometimes for some companies all they want is high accuracy. Like for some companies they're really like, I don't care how you did it, or I don't care why the model's like that, just give me high accuracy. There's some companies naman that are more like, oh, I want you to be able to explain it. Like it's not enough for you to give high accuracy. I would even settle for a lower accuracy if you're able to explain it. Because there are models, that's like how you choose models. There are some models that are easier to interpret, like yung mga regression models. If you recall your statistics, di ba kasi sa regression you have they can literally give parang numbers to your features to show yung parang the weights, kung ano yung ano. So that's a very interpretable model. But then there are some models naman that are really like kind of black box. Like neural networks are very black box. Like you don't know how affects it anymore. Pero as you know, like from you've probably heard in the news or in like articles, like neural networks are higher accuracy compared to like simple regression models. So it depends on your use case, which ones really would like suit your need.
Okay, ma'am. We still have another question here. Um, Owners, stakeholders love to see visualization for their decision making. Can you give us another library that can showcase an enterprise data visualization?
Okay, all right. So data visualization, there's a lot of tools. The ones I've shared are the most common ones and also like the easiest to use. So we have here, what do you call that? Matplotlib and Seaborn for the simplest tools. One thing that I initially had planned to teach, but I was thinking of time. One thing that is very popular right now, like if you go to Twitter, it's called Streamlit. It's if you're familiar with Streamlit, it's a data app tool wherein you can deploy, like you can share your results. I'm not sure if I'll try to tayo. Here, let's try. Yeah, so like Streamlit is like currently right now it's like a hot tool that people use because you're able to what call that? You're able to export to deploy your models with just a few lines of code. So it's very user friendly. And right now there's a lot. So here like for this one like you can do GAN and all that. So all of these things. So for people who are into visualization, they have a lot. It's like it also allow you to make visualizations using that package. So this is one, Streamlit. And then within Streamlit, you can apply other common tools such as Bokeh. If you guys are familiar with Bokeh, that's also another one that people are using. But here, I encourage you to check this out, like Streamlit. You're able to make visuals with very simple and just go through the documentation that they have to see. Yeah, go to the documentation to see like what are how to use it. Like it's very user friendly. Pero yun, like this one, it's like a GAN model like there. Yung, if you're familiar, di ba yung mga apps right now that's trending on Facebook, like make me a younger, make me a girl or a boy. So here you can play with like the code and or like the features. So they're interesting.
Okay, ma'am. And we still have another one. Do we have an AI library that can detect an outlier on your data initially?
Outlier detection library. Okay, so the process that we used is the more manual way, right? So we use box plot and then we identify the outlier. The thing with outliers, kasi the one thing is actually the definition of outlier is also subjective. Like you can say that one thing is an outlier based on statistics. So this is a statistical definition of outlier, right? So it's like that way. So I'm actually not sure if there's a library that can automatically compute the outlier this way. But for some people, they also have a different definition of outliers because for them, like even if statistically it's like within outside the range where it's acceptable in the domain, like they still don't consider. But like yeah, I guess to keep the answer short, I'm not that familiar. It's a library to detect outliers that's as easy as like the ones we've been using.
Okay, ma'am. And we still have another one. Machine learning algorithms are numerous as of now. If given a data set, how can one determine which algorithm to be used for that? Is there any AI tool that can suggest you to that?
Yes. So I'm not sure if you guys are familiar with the term there's no free lunch theorem. So there is no absolute like this algorithm is what you need to use for this one. So there is no such thing as that in data science. It's really like an exploratory way of you have to look at different algorithms and then look at the best performance. So if you've read if you've read some of the papers on machine learning, you will see that's how actually they report. They put in like the algorithms that they use. For example, K means something else like that and all that, and then they have a table of like accuracy and all those things, and that's how they like say that okay, this is the best algorithm to use. Because there is no like if this is the data set, this is the algorithm. There's no such thing. It's really like that's the point of modeling. Like you have to determine the algorithm, the hyperparameters by doing this data science process, and like that's the beauty of data science, right? There are now certain companies that try to automate that. If you're familiar with Data Robot, that's an example of a data science company that like, and there's also right now what we call Auto ML in like Google. I think yeah, if like Google's offering Auto ML, but right now like the extent of Auto ML is still not as extensive. Like the output of Auto ML is fine for simpler projects, but not to the extent of like the more complicated projects, which is the usual like big data sets that we have. It's usually not that and yet for like real world data, since it's complex, usually doesn't fit well with AutoML. But for simpler cases, sometimes yes, you can use those mga AutoML um, tools that are attempting to like automate the one we did, the data science process.
And someone in the group asked about, hello, I wasn't able to hear the whole talk. Are you keen to providing us a copy of the Jupyter notebook that you use for your talk? Thank you very much from PCPasia at up.edu.ph.
Okay. Let me share again the GitHub where it's saved. So if you weren't able to join us at the start and you want to be able to check the notebook, it's uploaded here. So at github.com, Julia's USEP _AI _ML. So feel free to feel free to pull the code from this repository. And then if you have questions, feel free to drop me a message in LinkedIn.
And I think last question, ma. Um, the question is, do you have any advice for those who aspire to be a data scientist?
Yes. So this is a very good question, and this is actually something that like I have been in your shoes a couple of years ago because I've also been like an aspiring data scientist before, and even now I'm still a very I still believe that like I'm a very junior data scientist. There's still a lot more rooms to grow. Advice for data scientists: one is skill for a data scientist. Number one is be curious. Always ask questions because the best data scientists are those who are able to answer good questions. So you have to be curious because um, it's really about like finding like looking at things and then trying to see like how can you solve it. Like that's like a very, I guess that's applicable for all, but for data scientists, really being curious of like, okay, um what is it that I want to answer? Or like you look at something and you're like, oh, is there a data driven way to do that? Is there a data driven way? So like be curious. So you start by asking questions, and then from there you can start being more data driven by thinking, what are the data sets that are available, or what are the data points that could be applied to that particular use case? So that is like one way to like start having that mindset of a data scientist. And then pero for a more like applicable application advice, one is that there's a lot of resources out there. So right now, like this is an age of there's an age of information. There's so many resources. Um, just get started. Get started. Like go to towards data science. Go to join yung mga data science group in Facebook. Be part of the community. So just get started. Start coding. Don't be afraid to start small. Don't be afraid to like just do simple projects at first. And yeah, and then from there you just gradually grow.
And we have, I think, another one, ma'am. Any insights on which portfolio projects are attractive to Philippine companies looking for data scientists, analysts?
Okay, so right now data scientists are still very in demand because there's still a scarcity of true data scientists. And the data science for you to be able to like those that are true data scientists, because like right now data scientists kind of being thrown everywhere as a term. For true data scientists are able to do a real machine learning projects. There's still a scarcity. There's not a lot of them. So in terms of portfolio project that are attractive to companies, I don't think there's any. It's really more of like being able to showcase your skill. So you're free to do whatever passion project you want. Like if it's into sports, you can do that. If you're like into basketball, do like predictive analytics of like who will be drafted in the next pick, something like that. If you're into like more on the social science or into politics, maybe do something related to yung mga, I don't know, like something related to like news entry. So there's really no particular topic that companies are looking for. What they're looking for is really more of your content, your skills. So are you able to do your model correctly? Were you able to communicate your output efficient? Parang were you able to communicate theory? So that's the more of the skills that they're looking for rather than like a specific topic. So just make sure that, of course, in your portfolio, it is a data science project, meaning that you are able to use your machine learning models correctly. And I think that should be good for most people who are hiring junior data scientists. And usually it's just this one. Just if you have a GitHub with a machine learning project, that's already like you're already above the you're already like you already have an edge compared to majority of the people who are applying, because majority of the people don't really have like enough entries in their GitHubs to showcase. Like they don't even have a portfolio. So just get started. And yeah, and then share that with people. Mhm.
So any questions from the participants or from the audience? And since we have a limited time, the remaining unanswered questions will be sent later to Miss Julia, and the answers will be posted in the group page. So our group page is the artificial and the one you just recently joined, and we'll be posted all the related materials and stuff there. And thank you very much, Miss Julia, for a very informative discussion about machine learning. We really appreciate having this topic in our event. You highlighted and discussed each part of the machine learning or the data science process. And then you presented to us to work around on how to code and to process the data using Jupyter. Miss Julia, we owe you a special vote of thanks for taking your time to be here for this event. Again, ma'am, thank you very much.
And thank you very much as well. And it's an honor to be here with all of you guys.
And please look forward for our afternoon session with our speaker, Mr. Albert Humul, starts at 1 p.m. And please be reminded to obtain the certificate of attendance. Please have some time answering the feedback form. There is a simple exercise included in the feedback form to be answered, prepared by the speakers. Please answer the exercise for us to count your attendance for this event. The link of the feedback form will be posted at our group page right after the event. And that ended our morning session for today's webinar event. Thank you. Enjoy your lunch, everyone.